Good morning, Dr. Lee. This is Srijana Gajurel, one of the data science at your company, and I would like to present my analysis today. I would like to begin from today's agenda. I'm going to start from the introductions, data preparation that I made for this analysis, k-means clustering, logistic regression, decision tree classifications, random forest classification, and the further improvements. Now let's discuss about the project overview and the objectives. The goal is to use the machine learning technologies for the segment customers to predict the policy claims, focusing on the clustering and the classification task. Here is the objectives: using the clustering for the k-means segment for the customers and the classification to predict the claims, risk using decision tree and the random forest models. Here we are using datasets, ability datasets for the customer clustering and the claims data for the classification task like predictions and the risk labels. The aim is to improve the decision makings in underwriting and customer risk management. So here is the k-means clustering, which is the unsupervised learning technologies. I am using it with the Abilitic dataset and identifying the 3 optimal clusters with the ALBA method. These clusters segments customers into distinct groups like examples, high risk, low risk, etc. We provide the key insights for underwriting and customer segmentations with the hierarchical clustering, also applied to validate the clusters. So here is the visualization of the clustering analysis, which is ALBA method for the optimal K. We can see the number of clusters here as a K and the inertia. And we can see that the 3 is the optimal clustering here. So here is another visualization, which is bar plot for the number of data points in each optimal clusters, like each clusters, how the data are using. And you can see that the 0 clusters is around 20,000 counts. The cluster 1 is around 50K. The cluster 2 is close to 20K. Here is the logistic regression model for predicting encoded total payments, and we got an accuracy 83.69%, which is great with the scaling, and versus 83.37% with the raw data, which helps to improve the prediction accuracy for higher coded payments. Let's discuss about the logistic regression with the standard scalar result, which is having the accuracy score of 83.87%. That means makes the predictions by the model very correct, which is the overall accuracy. The classification report is showing that 0.87 for the class 0, which is no claims, measures how many of the predicted positive samples are actually positive. Also for the class 1, the precision is 0.87. Similarly, the recall, which measures how many of the actual positive samples were correctly predicted. Class 0 recall is 0.78 and the class 1 recall is 0.87. The confusion matrix shows the true negative, true positive, false positive, and the false negative values for the model. Let's discuss about the decision tree, which is the supervised learning methodology. I created 2 decision tree for the presentations, and which is with the tuning and without the tuning. With the tuning, I got a max depth of 20, which is also being the 99.41% with the key features, and that looks very, very overfitting, and then we need to take care of the overfitting for this model. This is the visualization of the decision tree model, which is classified with the claim and the no claim data. Another model is random forest model I would like to discuss about, which is with the 1000 trees and the max features equal to 3, and I achieved 96.96 accuracy, which is excellent in predicting the no claims, total paid, and the claim types, whereby the predictors. The model performed well and showed no signs of underfeeding. I'm making it the best model as I am finding and comparing with others. The other models were kind of overfeeding, and the random forest model strikes an optimal balance between the accuracy and the generalization for the general classification task. Let's discuss about the confusion matrix for random forest predictions. We are able to get 7,185 true negative, which is correctly predicted as no claims. 0 as false positive, no correct prediction as claim when it was no claims. The false negative 249 incorrectly predicted as no claims but were actual claims. True positive 1906 correctly predicted as claims. The model performs well on no claims prediction but missed 249 actual claims. Let's discuss about the gradient boosting classifier. Another classifier I tried to achieve while modeling. The 99.0% of the accuracy I got with this, which is effectively classifying both no claims and the claims with total paid as the key features. It's ideal for high precision tasks, though it requires more computational power and it looks very overfitting, and we need to work on the overfitting issues on this one. Here is the model result summary, and we can see the different models has different score. Now let's discuss about the policy risk model visualizations. With the claims yes or no, a majority of near to 35,000 of the policies did not result in a claim. Around 10,000 policies had claims. Policies with claims in first 30 days yes or no, most policies around 35,000 did not experience a claim within the first 30 days. Around 8,000 policies had a claim in the first 30 days. Policies with large claims, yes or no, most policies, around 42,000, did not result in large claims greater than $10,000. About 3,000 policies had large claims. The charts indicate that while most policies do not result in claims, a smaller percentage experience claims, especially large or early claims, which may represent higher risk. Let's discuss about the comparison and conclusion. Random forest model with 1,000 trees, max feature equal to 3 is the best performer with 96.96% accuracy. Logistic regression model scaled 1, 83.69%, unscaled 83.37%, and the tuned decision tree 99.41%, gradient boosting is 99.01%, which is strong for high risk claims but require more resources. The conclusion is the random forest is the best choice with logistic regression for simpler tasks and tuned decision tree and the gradient boosting for complex scenarios. The model choice depends on the general goals. I see there is a further improvement needed for the modeling because there is overfitting issues I'm seeing with the modeling. So for that, I would suggest to go with the limit model complexity, like reduces the max depth, apply the regularization, and use pruning. The cross-validation, use k-fold cross-validation to ensure generalizations. The regularization is apply L1, L2 regularization in logistic regression and pruning in decision trees. Hyperparameter tuning, use grid search to optimize parameters, reduce features, focus on key features to minimize noise, and the increased data, more data helps prevent overfitting. At the end, I would like to say, despite of some overfitting, purchasing the evaluative data is still valuable. It provides key insight into customer segmentations, helps identify important predictors like total paid and claim type, and supports better underwriting and pricing strategies. Overfitting can be addressed with model tuning, and the data's long-term value will improve decision making for the general. Thus, it's a useful investment. Thank you.